Good morning, guys. Today is the lesson 4.5, and you're going to learn how to solve radical equations. And in order to do that, I'm going to go over the steps first. So the steps in solving radical equations is number one, you need to get the square root alone on both sides. I guess here, both sides. Okay, you're going to get them alone on both sides. So it should look something like this. Radical equals to radical. The step number two is going to be opposite of square root is a square. So you're going to square both sides and solve for variable. And so hopefully everybody knows that square means opposite of square root is square. So that means you're going to square both sides. And the square and the square root will cancel. And then you just solve the things that are underneath the radical side. So to start, we're going to start what is a radical equation. Radical equation is when you have a radical sign. An equation, anything that's an equation always has an equal sign. So a square root with an equal sign is called a radical equation. Okay. Extraneous solution, that's a new term you're going to learn today. Extraneous solution is what we call a fake solution that does not work. So for example, if I get a solution that results in a negative square root, this is not possible. This is we're not able to solve the negative radicals. So this would be no solution in this case. Okay. So let's see if we can start solving and go through the examples and see what would that look like. So the first example we have is they want us to solve each radical equation expression and check for extraneous solutions. Then we want to circle the number of real solutions that radical equation has. So once we are done solving, we always have to reflect back and say, hey, is this a fake solution or is this solution going to work? So let's start. The first thing I want you to look and say, oh, do I have a radical by itself? And in this case, radical is already alone on one side. So I know opposite of square root is square. So I'm going to square left side. Well, whatever I do to the left side, I also have to do to the right side. So I'm going to have my radical and square cancel. So I have x plus 6 equal to 64. And now I just need to solve. I only have one variable, so this should be pretty straightforward. You subtract 6 from both sides, and x is equal to 58. Okay, so it looks like I have one solution. Now, how do I check to make sure that this is correct? I plug it in backwards. And so you would have a square root of 58 plus 6 is 8. And I get 64. Square root of 64 is 8, so that works. So I do have one solution. When we look at B, notice in B that I do not have a radical by itself. So that means that this positive 3 is going to have to be moved to the other side. So I'm going to have radical m equals 2. In this case, now this is negative 3 plus 10. And please write this out. A lot of students do this in their head, and this is when they get in trouble. So negative 3 and positive 10 is positive 7. So now I know opposite of square root is square. So I'm going to square both sides, and I get m equals to 49. Again, how many solutions? 1. Let's see. Um, let's see if I plug it back in, if this would work out. So I have a square root of 9 plus 3 equals 10. Square root of 9 is 7. 7 plus 3 is 10. 10 is 10. I check out, no issues. Okay. Let's look at the next example, C. Notice that I do not have a radical by itself, so the first thing, I'm going to move my 6 over to the other side. And in this case, I have a radical 2z equals to negative 6 minus 2. And you should know that negative 6 and negative 2 is negative 8. And can you ever get a negative number once you square root? And the answer is no. So the answer is no solution. So in this case would be none. Okay. Let's move on. Let's look at the next one. So in the next one, we are doing D. And notice in D, again, I don't have the radical by itself. So this 6 has to be moved to the other side. So my square root of B equals to negative 6 plus 1. And for radical B, a square root of 4B minus 5. And right away, you know that you cannot get a negative radical when you take a square root. So the answer would be no solution. And no solution means none. So if you look at E, you'll notice that we're getting into a little bit more complicated stuff. You notice that I have a square root minus square root equals to 0. And in this case, in a quadratic equations, when we were solving, everything had to be equal to 0. Well, in this case, it's opposite. We need to make it each radical on one side. So basically, I need to move this radical that's a negative to the other side. And so you move it by taking this positive. So basically, again, if you want to just visualize it, it just changes signs. So I have radical x minus 1 equals to radical x minus 1. And now I have 2 radicals on each side. I know that if I square them, the square root would go away. So all I'm left is x minus 1 equals to x minus 1 because my square and the root cancels. And now I need to solve for the variable. So the first thing you're going to move is x. And when you move the x to the other side, so that means minus x on both sides, what happens to your x's? Notice that your x's will cancel, and you are left with negative 1 equals to negative 1. Is this a true statement? The answer is yes. So that means I will have infinitely many solutions, which means whatever number I plug in for x, it's going to, sorry about that, it's going to work out. So it's infinite number of solutions. Let's look at f. In this case, notice that I already have a square root alone on one side, so I can do the opposite. So that means I square, and I have to square then this side. So that means I have w squared equals to 2w plus 3. And now this should bring you back to last chapter when we were solving quadratics. And when you solve quadratics, everything has to be where? On one side. So I would have w squared minus 2w minus 3 is equal to 0. And so this should be a review for you. I have 3 terms, no GCF. What is the first thing you need to do? T-chart. So I want to get negative 3 when I multiply, negative 2 when I add. So it's kind of straightforward, negative 3 and 1. So I have w minus 3, w plus 1 equals 0. Then comes your favorite, 3 s's. Split set, see what you get. So w minus 3 equals to 0. W plus 1 equals to 0. So I have, looks like, two solutions. And so remember what I said earlier, you always, always, always have to look at your solutions and see if those solutions would work. So if I go back to the beginning of the problem, and if I use 3 for my w, that would be 2 times 3 is 6, plus 3 is 9, and square root of 9 is 3, and 3 is equal to 3, so that checks out. But look what happens when I put a negative 1. I would put negative 1 equals to square root, and right away I know that this is not possible. So negative 1 is what we call extraneous solution. And so how many solutions do you have? You do have one solution. So you need to be careful with that. Okay. So this is pretty much it as far as the equations go. Let's go in the back. And now we're going to talk a little bit about the word problems. So let's see what that looks like. So in the first problem that we are going to look at, it's a student solved oh my gosh, this is driving me crazy. Okay. Student solved the equation square root of 3 plus 4 equals r below and found that the solution is 4 and negative 1. Describe and correct the student's error. So the first thing we are going to do is we are going to solve everything from scratch just to make sure that the student did the work correctly. So square root of 3r plus 4 equals to r. So the first thing we need to do if we are solving ourselves, we would square both sides. It looks like the student did that. So my root and square cancels, and so you have 3r plus 4 equals to r squared. So now I have a quadratic equation, and remember from last chapter, we moved everything to one side because it's a quadratic. So you end up with r squared minus 3r minus 4 is equal to 0. And now that I have the three terms, I have polynomial, we cannot GCF, we are going to t-chart. And I want to get negative 4 when I multiply negative 3. So my answer has to be negative 4 and 1. So this would be r minus 4, r plus 1 equals to 0. 3 s's, split set, see what you get. So you add 4. So r is positive 4. And r is negative 1. So I have two solutions. That's what he got, but they're telling me that it's not correct. So remember what I need to do. I need to go to the beginning of the problem. And if I plug in negative 1 here for r, I will notice that I get, in this situation, square root is equal to negative number. And I know that that's not possible, so I can cross it off as not a solution. And so that means this is extraneous solution. Extraneous solution means I did everything mathematically correct, however, it does not work out, so it's kind of like a fake solution. So the only solution is r is equal to 4, or one solution. Moving on, next year you're going to have geometry, and you have to know how to calculate the volume, and most of the time the formulas are going to be given to you. So in this case, you have a sphere, and surface area, the formula to find the radius of a sphere is given to you. So this is your sphere radius formula. S represents the sphere's surface area. Suppose a sphere had a radius of 8 centimeters. What is the surface area? Round to the nearest 100th place. So in this case, the radius is given to me. It's 8 centimeters. They also give me the formula, so which is square root of s over 4 pi. And in this case, I need to now plug in information that they give me. And the information that they give me is a radius, that's 8. So I'm going to substitute 8 is equal to square root of s over 4 pi. Looks complicated, but in reality it's not. What you have learned that anytime you have a square root alone on one side, to do anything with it, you need to break it out of the square root, which means opposite of square root is square. If I square the left side, I have to square the, if I square the right side, I have to square the left side. So 8 squared is 64. My square and square root cancels. So s over 4 pi. They want me to find the surface area. So surface area is my unknown. I'm going to circle it. This is what they want me to solve for. So what did I teach you to do? If you have a division, opposite of division is multiplication. So that means that you will multiply both sides by 4 pi. And so now in this case, I have 4 pi times 64 equals to s, because these two pi's would just cancel each other out. When you're calculating, you are going to put pi in a calculator. You're not going to put 3.14. So because the calculator carries all the digits, and so you will be more accurate in actually producing calculations. So in this case, s is equal to, you're going to put 4 times pi times 64 in a calculator. So go ahead and put it in a calculator. And they want you to round to the nearest hundredth. Hundredth place is 2 decimal places. So 2 decimal places after the period. So this is 1, 2. 2 places. 2 places after the decimal place. So if you did this correctly, you should have gotten 804.2477. And because you're rounding to the hundredth place, this is the place. However, notice that 7 is a number that's bigger than 5. So that means that when you're rounding, you would have to round 804.25. And that is your surface area. The units we are using, it's centimeters squared, because area is always expressed in units squared. Okay, so that's the lesson for today. The rest of the time is yours to do the homework. Please make sure that you show your work step by step. And one more time to quickly review the steps. Radical equation is the one that has a square root. Your goal is to leave the square root alone on one side. Opposite of square root is square. And by squaring both sides, you are able to solve for the equation. That's it for today's lesson. Thank you for listening, and good luck.